Okay, one of your classmates asked me if I'd make a video. Excuse me, coughed a little bit. On finding possible rational roots. So if you wanted to see this video, go around and say thank you, Noah. That was so kind of you. Now I call it finding the but that's just abbreviation of possible rational roots, PRR. Now, notice that when I'm solving something, I can solve it by factoring, if possible. Not everything's factorable. Completing the square quadratic formula if the highest power is 2. But also notice if I'm allowed to solve it by factoring, it's the factors of this that goes with the factors of this. Now I'm just going to factor this. I hope you remember how to do it. But it'd be 3x plus 1x plus 5. So it's 15x plus 1x. So you go 3x plus 1 equals 0. X plus 5 equals 0. So x equals negative 5. X equals subtract 1 divided by 3, negative 1/3. But what's important about this, that the answers have to be factors of this with this, or it couldn't work. Because it has to be this and this is this. This and this is this multiplied together. So I know not to try 7 because 7 isn't a factor of 5. And it's not a factor of 3. So to find the PRR, if I had this problem, x to the 4th plus 7x squared plus 6x minus 3, I would know that it's the factors of this divided by the factors of this. Those are the only ones that could be possible. Now, none might work, but those are the only ones possible to get a rational answer. Now, it does not help me if I'm looking for irrational or imaginary. So for this problem, it'd be plus or minus 1, plus or minus 3. That's all that could work because it's factors of this. This is 1, so it doesn't change these factors. So I've gone from infinity to try 4. So if I want to do this one, 7x to the 5th plus 6x plus 5, it'd be the factors of the last one, plus or minus 1, plus or minus 5, divided by the factors of the highest powered term coefficient. Highest powered term coefficient. So it'd be plus or minus 1, plus or minus 7. Those are the only possible factors. So it'd be 1 divided by 1, plus or minus 1. 1 divided by 7, so plus or minus 1/7. Plus or minus 5 divided by 1. And plus or minus 5 divided by 7. So we've gone from infinity number of answers, or number of choices, I should say, to 8. Now I know there's only 5 answers for this, and there's only 4 for this. Also remember, imaginary answers have to come in pairs. So I could not have 5 imaginary answers. At most, I could only have 4. So let's look at this one. 6x to the 8th plus 4x to the 6th plus 5x to the 5th plus 3x to the 3rd plus 7x squared plus 4x plus 8. And this will be my last one. Now, since there's only plus signs, I know that a positive number could not be a rational answer because when you're adding positive numbers, it can never get you to 0. You got to have at least a negative or a minus in there somewhere. But my possible rational answers would be the factors of 8 would be 1, 2, 4, and 8. Divided by the factors of the highest powers term, the highest powers terms coefficient. That's hard to say. So it'd be the factors of 6 plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now, I might ask you to find the possible rational roots for this many choices, but I wouldn't have you solve a problem with this many choices. But here we go. Plus or minus 1 divided by plus or minus 1 is plus or minus 1. 1 divided by 2 plus or minus a half. Plus or minus a third. Mercy. Plus or minus a sixth. Who picked this problem? 2 divided by 1 is 2. Now, 2 divided by 2 is 1. I already have that, so I'm not going to do it again. 2/3. Then 2 divided by 6 is 1/3. I already got that. 4 divided by 1. 4 divided by 2 is 2. Good. We already have 2. 4/3 we don't have. But 4/6 is 2/3. We do have that. 8 divided by 1. I'm going to have to take a nap after this. 8 divided by 2 is 4. We already have 4. 8 divided by 3. And 8 divided by 6 is 4/3. When you reduce it, we already have that. So it'll be 3, 6, 9, 10. That's 20 choices. That's still better than infinity. But, so, if you watch this video, thank Noah. Thank you, Noah. If you didn't watch this video, well, don't thank anyone then. That wouldn't make any sense. Hey,